So let's go back to Jeff and social media and see if we have any questions kind of in the bank waiting for us.
All right. Well, we do have actually a couple questions here, and the first question is a kind of a science question, and it has to do with something called plate tectonics. I don't know if anybody's ever heard of that, but the question is, what kind of movement created the Himalaya mountains, the mountain range? What kind of movement, what kind of plate tectonic movement created that?
Okay. Well, yeah, I mean, no worries on getting that open. I think I got the question. So thinking about tectonic plates and plate movements, there are essentially three types of tectonic plate movement, and maybe I'll just start with what tectonic plates are. So if we could jump to my screen, I just have a very basic map of the world up, divided into some of the really general tectonic plates that the world is divided into. So generally speaking, the Earth is covered in a layer called the crust. It's the thinnest layer of the Earth. Down below the crust, we have the mantle and the core. The mantle is a semi-liquid piece of rock that's super hot and under a lot of pressure. But the crust is all the stuff that we live on and that forms the surface of our Earth. And that's not just land crust, that also includes ocean crust. So like the bottoms of the ocean, that's oceanic crust. So the image that you can see sort of shows the really basic divide, breakup of the Earth into different tectonic plates. And that semi-liquid mantle underneath is getting heated from the core, creating a flow. And so there is a very, very slow flow movement that sort of shifts these plates around, and they either knock into each other or scrape each other or pull apart from each other. And you can see from some of the arrows on this map that there's a variety of kinds of movements. So for example, you can see here that the African plate and the South American plate, according to the arrows, are pulling apart from each other. And that's actually the Atlantic Rift Valley. So there's an area in the bottom of the Atlantic Ocean where the ocean is spreading. And so the Atlantic Ocean is actually growing very slowly as these two plates spread apart. But we were concerned about the Himalayan mountains and how they formed. So the Himalayan mountains are a mountain range along the northern border of the country of India and Nepal. So I can pull up another map here. So this is a basic map of the Indian plate and its movement. So about 70 million years ago, the Indian plate was located further south of the Eurasian plate. And over the course of the last 70 million years, it moved and rotated, as you can see in this picture here, until it collided with the Eurasian plate. And what you essentially had happening was the Indian plate was pushing into the Eurasian plate, and where they meet, they form what's called a convergent plate boundary. At convergent plate boundaries, you typically get uplift. So essentially, you can imagine, like, I don't know, smashing two pieces of, I don't know, bread together like or something.
Yeah,
as they smash into each other, they'll rise up where they meet each other, and that's sort of like mountain building. And so again, that's called a convergent plate boundary. So there are three. Oh, hold on, sorry. Oh geez. Oh geez, gosh. Oh gosh, oh geez. These are the three kinds of plate boundaries, the three general types of plate boundaries. So a divergent plate boundary is where two plates move apart from each other. A transform boundary is where two plates scrape against each other in a sideways motion. And then the one we're looking for, the way that the Himalayas were formed, is through a convergent plate boundary right here, where you get two plates smashing into each other, creating that mountain uplift. Himalayas are the tallest mountain range in the world, and they're also an actively growing mountain range. And so I can't remember the exact figure, but the tops of the Himalayas are growing by something like, several centimeters a year. So very slow growth, but they actually are rising as that Indian plate continues to push into the Eurasian plate.
I was wondering about subvergent. Is that another one as well? Or is that considered convergent?
No. So they're slightly different things.
Okay.
So convergent just means two plates come together. Divergent just means two plates move apart.
Go apart.
But there's what's called subduction.
Oh,
so subduction
yes.
is when one plate moves underneath another, and that has to do with density. So there's by and large, there are two types of plates. There's oceanic plates and continental plates. And the reason that there are different plates is because over time, as these plates get smashed into each other, some of the plates, as Becca was saying, will get pushed underneath other plates. As they get pushed down, they'll join the mantle, and the rock that makes up that plate will melt and just become sort of a part of the mixture of the mantle. As this happens over time, what you ultimately get is the lightest materials, the elements that are the lightest, will float upward. The denser stuff, the heavier stuff, will float downward. So over time, what we've got is oceanic crust. Oceanic crust is denser and heavier than continental crust, which is lighter. So when a continental crust and an oceanic crust knock into each other, the oceanic crust, being more dense, if this is the oceanic crust, will go below the continental crust, which will rise above. Now, you do have instances, Becca, of two oceanic plates knocking into each other, and then it can be kind of more of a crapshoot, or two continental plates. You know, and really at that point you would get probably mixing. Some pieces would go below, some pieces would go up. But in the case where you've got an oceanic plate knocking into a continental plate, because of the density of the oceanic plate, it's going to have more iron in it, whereas continental plates will have more silica, making it lighter. That's the reason that the oceanic plate will subduct below the continental plate.
And the Indian plate, that boundary is two continental
plates, exactly.
So they're both.
So they're, and surely some pieces are subducting and some pieces are raising, and it's largely a mixture.
Okay, gotcha.
Yeah.
Thank you for clearing that up for me.
No worries at all. Happy to do it. That's why I'm here. That's why they pay me the big money.